Hello, hello. I'm back with video number 9 in this series of Physics C Mechanics multiple choice questions. So this problem opens with a pretty long introduction. I'll zoom in by moving my computer. Pause it if you want to read it. I'm going to read it out loud for you. So here's a little diagram of it. Particle A and B, each of mass m, move along the x-axis, exerting a force on each other. The potential energy of the system of the two particles associated with the force is given by the equation U, that's potential energy, is equal to B over R squared, where R is the distance between the two particles and B is a positive constant. At the time t equals 0, particle A is located at x equals 2d with an initial speed of v naught to the left. So this is our introduction for problem 9 and 10, which I'm going to get to in my next video. So problem 9 reads, at time t equals t1, particle A is traveling with a speed of 2/3 of v naught to the left. The speed and direction of motion of particle B is A, 2/3 v naught to the left, B, 1/3 v naught to the left, C, 1/3 v naught to the right, D, 2/3 v naught to the right, and E, 5/3 v naught to the right. So let's talk about what is at play in this question. So these particles, one initially stationary, the other one moving towards the other one, we have two times. So because of that, you can tell that this problem is going to be associated with conservation of momentum. And this is going to be linear momentum since they're moving just in a straight line on the x-plane. So we're dealing with momentum. So momentum is equal to, like, momentum for one particle is mass times velocity, but we're going to conserve it. So we're going to add up the momentums of the two particles at the start and set that equal to the momentums of the two particles at the end. So our initial momentums, we're going to have the mass. There's not a lot of room here, but I'm going to try to squeeze stuff in. So we have mass 1 times velocity 1 initial plus mass 2 times velocity 2 initial is equal to mass 1 times velocity 1 final plus mass 2 times velocity 2 final. Alright, and then right away we can see each of mass m, the particles have equal masses, so we can cancel all of these out. All these are equal. That's not going to affect the problem. So now let's look at what information we're given. So so initially particle B does not have a velocity. So I guess I accidentally changed this from A to B to 1 to 2, but we can call A 1 and B 2. So this is 0. Let's get rid of this also. And the initial velocity here is v naught. So v naught is equal to the two n velocities added together. And here we're told at time t equals t1, so this is our initial time. This is all our momentums at t1. So particle A is traveling with speed 2/3 v naught. 2/3 v naught. And this is particle A. So then if we add the final velocity of particle B, that's what it's going to look like. And then we can very easily solve this. We can subtract 2/3 of v naught from each side, and we're going to get the final velocity of particle B. So velocity of particle B final, which I wrote as velocity 2 here and here by accident, but it's going to be the velocity of particle B at the end, is equal to 1/3, because we're taking the whole and we're subtracting 2/3, 1/3 of v naught. So now we can cross off a lot of these. This says 2/3, it's not 2/3. This says 2/3, it's not 2/3. This says 5/3. No, that's wrong. So now we're left with B and C. Is this particle traveling to the left or the right? So we have to look now at whether these particles are attracting each other or repelling each other. So at the start, this is not moving. This is traveling towards this particle at initial speed of v0. At time t1, A is traveling at a slower speed towards B1. So that means we know that since this was traveling at v0, A is now closer to B, and it's traveling slower. That tells us that these are repulsive. There's a repulsive force between the two particles. So if they repel each other, and A is exerting a repulsive force on B, and it's repulsive, it's going to push B away. So then our speed that we've gotten for conservation of momentum is going to be pushing B this way. It's going to be pushing it away. So that is to the left. And yes, that is my answer. Bam. So 1/3 v0 to the left is our answer. Let me know if you have any questions, comments, concerns about this problem, and remember, check back in for question 10 based on the same scenario. Alright, thanks for watching.